We're looking at three different types of implementations. One is the array collection, one is the sorted array collection, and the other one is the linked base collection. For both contains and get, these are the transformers. With sorted array, we use what's called the binary search, which is very efficient in log n to be able to achieve O of log n, whereas both array based or link based, which are not sorted, with O of n. On the flip side, both add and remove for sorted array becomes cumbersome because remember, we have to maintain the natural order of those elements. So it's not as simple as adding the elements to the beginning or end of the arrays anymore. We have to ensure that insertion and deletion of the elements follow those order. So there's an extra cost in adding and remove elements in sorted fashion. You don't have that type of cost for adding the elements in the cases of array collections and link collection, because you simply do so at the end of your array for array collection implementation, since you're maintaining the index, which is location. You don't have that issue either with link-based collections, since the added elements will just be at the beginning of your linked list by repointing head to the new node. However, for both removes inside array-based and link-based collections, we still have O of n. And remember, O of n is really for finding the element. In all of the implementation approaches, size is O of 1 because we are always keeping track of the num elements. So the retrieval of num elements is O of 1. Same thing with is empty or is full, because you can simply compare the num elements with respect to the size of your initial capacity, even though linked list collection doesn't have an initial capacity, because you can simply grow the linked list by adding more elements to it, unlike sorted and array collection, because they are bounded by initial size. However, with the sorted array collections, you can invoke the enlarge method as needed to double the size of your initial capacity. So let's step back again and look at these collection implementation and see what type of problems are more suited for each of these. I would say if you have a problem that requires maintaining the order of elements, either by their natural order or by their inherent or implicit values inside the elements, then you can consider sorted array collection, especially if there is a lot of reads, meaning a lot of requests coming into your collection looking for something. And reads is super efficient because O of log n as compared to the other two, which requires O of n. So use sorted array collection when one, elements are sortable, two, and most of the time, the client just need to fetch information from this collection. For the other two collection implementations, your write, which is your add and removed, is much more efficient, especially when adding the elements than the sorted array collection. So if you have write heavy use cases, you may want to opt for array collection or linked collection than the sorted array collection, especially when elements are not inherently require sorting. And of the two collection implementation between array and linked list in a write heavy scenarios, if the number of elements is expected to be finite and small, you may define a fixed array in a collect constructor of n elements instead of having a linked collection, which requires several more pointers to hold the variables like previous and location. But let's say the size of your input throughout the lifetime of the application is large, then you want to opt for linked collection. So hopefully these scenarios illustrates the pros and cons, the trade-offs amongst the various collection implementation to give you some ideas on which one is best suited for what. This completes our discussions on the link-based collection implementation.